Hi, welcome back. In this question, we need to draw the shear force and bending moment diagrams for a cantilever beam loaded as shown in figure. First of all, let us label the points. Let this point be A, this one be B, and this one be C. Now let us start calculating the shear force. Since it is a cantilever beam, we start our calculation from the free end of the beam. Shear force at the point A will be 12 kilonewtons. That is, FA is equal to 12 kilonewtons. The sign convention is positive. Why? Because if we consider our section here, just at the left of point A, this 12 kilonewton force is acting in the downward direction. The right downward is considered as positive. That is the only reason this FA is positive. Now, let us move our section to just right of B. That means somewhere else here. This is our section now. So, what are the forces acting? The same 12 kilonewton is acting on this beam. This is our beam under consideration. So, only this force is acting. We are not including this 20 kilonewton. Why? Because this is on the left side of the beam. Therefore, the shear force at the point B, FB, is equal to 12 kilonewtons. This is just right of B. Now let us move our section to just left of B. That means here we are placing our section. That means we are going to include this 20 kilonewtons also. So from this point to this point is the beam under consideration. Therefore, the shear force at the point B, FB, is equal to 12 kilonewtons plus this 20 kilonewtons is also acting in the downward direction, that is right side. Therefore, shear force at the point B, FB, is equal to 32 kilonewtons just left of B. Now let us move our section to the point C at this point. Now, the shear force at the point C will be, what are the forces acting? This 12 kilonewton is acting and this 20 kilonewton is acting. Therefore, total 32 kilonewtons at the point C. Now coming to the bending moment. Bending moment at the point A is 0. That is, MA is equal to 0. Now let us move our section to this point, the point B. At the point B, how much will be the bending moment? Bending moment at the point B, MB, is equal to negative. Why? Because this is causing, this load 12 kilonewton is causing hogging moment. 12 kilonewtons multiplied with 3 meters. On calculation, we find that the bending moment at the point B, MB, is equal to minus 36 kilonewton meter. Now, let us determine the bending moment at the point C. MC is equal to negative 12 multiplied with 6, that is the perpendicular distance, minus 20 multiplied with 3. On calculation, we obtain minus 132 kilonewton meter. Now let us draw the shear force and bending moment diagrams. Let us locate the points. Shear force at the point A is at 12 kilonewtons. Here there is one point. And at the point B, also 12 kilonewtons. Then one more point is 32 kilonewtons. And at the point C, the same 32 kilonewtons here. Now let us join all these points. So let us join these points first. Then between C and B, it is completely a straight line. There is no other loads. This drop is because of this 20 kilonewton. Here again it is a straight line. Again this drop is due to this 12 kilonewton. So this is the magnitude of shear force at the point A, 12 kilonewtons, and here also 12 kilonewtons. Here it is 32 kilonewtons and here also 32 kilonewtons. And this entire diagram is positive. Now let us shade this entire area of the shear force. Now coming to the bending moment. Bending moment at the point A is 0. Bending moment at the point B is minus 36 kilonewton meter negative, and at the point C it is minus 132 kilonewton meter, somewhere else here. Now let us join these 2 points. It's a vertical line. Then between the points C and B, it is a complete linear line, straight line. Between point B and A also, it is a straight line. Gradually it increases because of this distance. This is negative. And let us shade the entire area of the bending moment diagram. So this is how we draw the shear force and bending moment diagrams for the cantilever beam. We start doing the calculation from the free end of the beam. Thank you.